This is the settings video. If you want to know what supports actually are and when you need them, there is a separate video for that. This one is the OrcaSlicer menu, setting by setting. Everything here lives in process settings under the support tab, and there are about 30 options in there, of which roughly 6 decide whether your supports are painless or miserable. We will go through the 4 support types, the 2 distances that matter, interface layers, the tree-specific settings, the painting tool, and a recipe you can just copy. One note before we start. Orca renames things occasionally between versions, so if a setting is worded slightly differently on your build, the meaning is still the same. Chapter 1, the 4 types. The type drop-down offers normal and tree, and each of those comes in an automatic and a manual variant, which is the part that confuses people. Automatic means Orca finds the overhangs itself using the threshold angle. Manual means it generates support only where you have painted it and nowhere else. So manual is not harder to use, it is just fully under your control. If you have painted your supports, you want a manual type, or Orca will add its own on top of yours. The threshold angle underneath decides what counts as an overhang. Leaving it at 0 lets Orca detect overhangs automatically, which is usually the right choice. If you set it by hand, the number is measured from horizontal, so a smaller number means it supports more. 30 is aggressive, 55 is relaxed. Chapter 2, the 2 distances. Top Z distance is the vertical gap between the support and the model above it, and it is the single most important support setting in the program. Set it to 1 layer height. If you print at 0.2, set 0.2. This is the setting to change first when supports weld themselves to your part. There is a special case. If you are printing PETG, which sticks to itself far more aggressively than PLA, go up to about 1.5 layer heights or you will not get them off. Bottom Z distance is the same idea underneath, for supports that rest on top of the model rather than the plate. Matching it to the top distance is fine. Support to object XY distance is the horizontal clearance, and it controls how close the scaffolding stands to your vertical walls. Around 0.35 is a good default. Too small and the supports scuff the sides of the part as they print. Too large and tall thin supports have nothing to lean on. Chapter 3, interface layers. The interface is the dense cap printed at the very top of the support, and turning it on is the biggest single improvement you can make to the underside of an overhang. Top interface layers set how many of those dense layers you get, and 2 or 3 is right. Fewer and the overhang still sags into the gaps, more is just wasted time. Top interface spacing controls how solid that cap is. 0 means completely solid, which gives the best surface but is the hardest to remove. A small value rather than 0 is usually the sweet spot, because it leaves the interface strong enough to hold the overhang but perforated enough to snap off as a sheet. There is also an interface pattern setting. Concentric tends to peel away in one piece, which is why a lot of people prefer it over rectilinear for the top interface. Chapter 4, the tree settings. If you pick a tree type, a separate group of options appears, and the defaults are good enough that most people never need to touch them. Branch angle controls how far sideways a branch can reach before it needs its own support. Higher values reach further and are less stable. Branch distance sets how far apart the tips are where they meet your model. Smaller means more contact points, better support, and more marks to clean up. Branch diameter is the thickness of the trunk. If your trees are falling over on tall prints, this is the number to raise before you give up and switch back to normal supports. Trees also have their own wall loop setting. More loops makes them rigid, which helps with height and makes them noticeably harder to remove. And tree supports genuinely benefit from interface layers in the same way normal ones do, so do not turn those off just because you switched type. Chapter 5, the painting tool. Support painting is on the left toolbar in the Prepare tab, and it gives you 3 brushes, Enforce, Block, and a clear tool to undo either of them. Enforce forces support onto an area the slicer missed. Block prevents it somewhere you know you can bridge, or somewhere the marks would ruin a visible surface. There is an on overhangs only option in that panel, which is genuinely useful. With it ticked, your brush strokes only take effect on surfaces that actually overhang, so you can paint roughly without creating supports in mid-air. Remember the pairing from Chapter 1. Painting with an automatic type means Orca adds its own supports as well as yours, which is almost never what you wanted. So the workflow is, switch the type to manual, paint your enforcers, block anything you want left alone, then slice and look at the result. Chapter 6. A recipe and checking it. For a general purpose starting point, tree automatic, threshold left at 0, top Z distance at 1 layer height, XY distance around 0.35, 2 top interface layers with a small spacing. For PL figures, that setup with plate only turned off will handle almost anything. For PETG, raise the Z distance as we covered. For big flat mechanical overhangs, switch the type to normal. Then verify it in the preview tab before you print. Set the view to line type, and the supports show up in their own color so you can see exactly where they landed and what they are touching. So pick manual if you are painting, set top Z distance to 1 layer height, XY around 0.35, turn interface layers on with a small spacing, and leave the tree defaults alone. Almost every support complaint comes down to one of two numbers being wrong, and both of them are distances rather than anything clever. Get those right once, save them into your process profile, and supports stop being the thing that ruins prints and go back to being scaffolding you barely notice. If this helped, subscribe to Layer Logic. The companion video covers what supports actually are and how to design, so you need far fewer of them.